Good afternoon, students. So we are in the session 2 of current electricity chapter. So already session 1 we talked about what is the basic idea of current. So current and what is it? எப்படி அந்த current measure பண்றது? Okay. So அதெல்லாம் நம்ம first sessionல cover பண்ணிருக்கோம். What is a steady state current? What is a variable current? Okay. What is the relation between the current and the charge? So all these things we have covered. So again, we also mentioned one point that in our syllabus, at least in the current electricity chapter, we will try to focus on the electric current that will exist in the metallic conductors. That is our main focus area. Okay. So again, what is the thing that we said in a metallic conductor? If you apply a voltage and solala or the potential difference apply panna, that means what? You are applying an electric field. Okay va? Electric field means that will be resulting in what? Force acting on that mobile electrons. And a conductor and so what is it? It will be having lot of these mobile electrons. So on the mobile electrons there will be force acting. So adanal the electrons will start what is it? That exact word that we use is what? Drift and solvanga. Okay va? The mobile electrons will start getting drifted. Idu patti we'll again talk about it. Okay. So because of that drift of the mobile electrons, the metallic conductors will be able to allow the current to pass through them. Okay va? So the charge carriers and so charge carriers in case of the metallic conductors, another what is it? It is the mobile electrons or the free electrons. Okay. So if what is the thing that we are saying? Because we are applying a voltage and solar or the potential difference, adanala the electrons are drifting. So we will be thinking, will there be a relation between the voltage or potential difference that you apply across a conductor? Conductor or rod madri edutha, we are applying a potential difference across the ends of the rod nechukonga, adukku current. So what is the amount of current that is going through that conductor? So will there be relation between these two or not? Okay. So adilande we will start the discussion today. So what is the thing that we are going to begin with? If there will be a relation between the voltage and the current. So main and we will talk about the metallic conductors. Okay. So if you are applying a voltage or potential difference V across the ends of the conducting rod. Okay va? Apply panna and we measure that the current going through that conducting rod evla I. So we want to understand if there will be a relation between this V value and I value. Okay. So this is an experimental observation and because we can change the value of, so like we can even do this in our regular school labs. Okay. And we'll keep changing. So V order value, we will take it as maybe 1 volt. What is the corresponding current? We'll change the value of the voltage applied. 2 volt panna, what is the corresponding current value? 3 volt panna, what is the corresponding current value? We can measure the recordings. Okay va? So we can measure these recordings. We will be able to understand what is the relation between the voltage and current. Okay. So if you maintain the temperature to be constant, so temperature change pannama, we will keep the temperature to be what? Constant. Okay. Then they have observed that the voltage and current, right, will have a relation. Idhil nariya cases varum, nariya conditions varum, adha pathi we will discuss about it in detail. But the relation that we are going to discuss first is what we call as a linear relation. And what is the relation we are talking about? Linear relation between the voltage and the current. Adhikada we also call it as what? Ohm's law. So Ohm's law gives us what? Ohm's law gives us the linear relation between the voltage and the current. Okay. So எப்போ இந்த volts law applicable ஆகும் அதெல்லாம் we are going to look at it. Okay, so பாருங்க, when we talk about the conductor, like the way we are discussing, right, if you apply a potential difference or voltage V across the ends of the conductor and we are measuring a current I ன்னு வெச்சுக்கோங்க, then the Ohm's law says that the potential difference across the conductor will be directly proportional to the current flowing through it at a given temperature. இது ரொம்ப important. ஏன்னா because we are not supposed to change the temperature அப்படியே தான் இருக்கணும். So we are doing all the experiments at 25 degrees centigrade. Anganadi, what is that? I'm just saying some temperature. You can do the experiments at 30 also, you can do the experiments at 40 also, but temperatures will be maintained constant. அப்படி நம்ம maintain பண்ணா, what is the thing that is observed in terms of relation between the voltage and the current? அந்த ரெண்டு நடுவுல what is the relation they observed? They observed that it will be a what? A proportional relation. Proportional relation சொல்லலாம். Otherwise we can also say it as what? Linear relation. Okay, so which means what? V will be proportional to I. Okay, otherwise V by I will be constant. V will be proportional to I. Otherwise we can also say it as what? V by I will be constant. Okay, so at a constant temperature நம்ம fix பண்ணா, the V by I or ratio, voltage applied by the current observed, other ratio will be what? Constant. This constant is what we are going to be calling as the resistance of the conductor. இங்க ஒரு பாயிண்ட் நம்ம clear ஆ வெச்சுக்கணும், என்னன்னா the resistance, right, will be definitely depending upon the temperature. And அதுதான் நம்ம சொல்றது, we are first fixing the temperature fix பண்ணிட்டு அங்க we are observing what is the relation between the voltage and the current. Okay, so because the V by I ratio, right, will be a constant, that constant will be depending upon the temperature. Okay, so the resistance of a metallic conductor, right, will be what? It will be a constant at a given temperature. It will be a constant at a given temperature, but it will be changing based upon the temperature. Okay, but if you are keeping a temperature to be fixed means, what is the observation we are having? V proportional to I, V by I will be constant. This is what we are calling as the linear relation. So what is it calling as? We are calling it as what? Linear relation. We are talking about one new physical quantity. What is it? Resistance. So whenever we are having a new physical quantity, right, first thing we should know what is the SI unit of the physical quantity, and if there is a popular CGS unit, and the what is the conversion between them. And we should also look at what is the dimensional formula of the particular physical quantity. We are talking about the resistance of that metallic conductor. Okay, so what will be the SI unit of the resistance? So the SI unit of the resistance, right, will be called as ohm, OHM ohm, and this is how we will be representing it. Okay, so using the Greek symbol notation, we will represent the ohm. Okay, like, when we look at the resistance, right, we are saying it is what? V by I. We can also write the unit in terms of, V is what? Potential, right, so it will be what? Volt, divided by I is what? Current. So we can write it also like what? Volt per ampere. But this will be what? Known as OHM ohm, and that is the symbol for this. Okay, so this is the SI unit of the resistance. What about the dimensional formula? The dimensional formula we look at this relation, right? Resistance is equal to what? Voltage by current. Resistance or dimensional formula, voltage and sonna, what is it? Voltage is energy by charge, right? Voltage and energy by charge. Current means that is a fundamental physical quantity itself. Other dimensional symbol is either we will use I or capital I or capital A. Okay, so we will use I as the dimension symbol for the current. Energy and sonna, what is it? M L square T power minus 2. That is energy divided by already I irka. Charge also will come to the denominator. Charge or dimensional formula, what is the dimensional formula for the charge? It is current into time, so it will be I into T. So overall M L square, denominator I into I means I square, so it will be overall I power minus 2. அதுக்கப்புறம் ஆல்ரெடி நியூமரிக்கல் t power minus 2 இருக்கா, இன்னொரு t on the denominator, so it will be what, t power minus 3. So this is the dimensional formula for the resistance. Check பண்ணுங்க. What is this? This is the dimensional formula for the resistance. Sometimes instead of calling it as a resistance, right, we will also call it as electrical resistance and சொல்லுவோம், but both are same. Resistance சொல்றதுக்கு பதிலா what is it that we generally also use, we can also use this electrical resistance and சொல்லிட்டு. Okay va? So this is about the concept of resistance, and this is based upon what, based upon the idea that the metallic conductors basically follow the Ohm's law. Okay, but like if you look at the resistance, right, it is a physical quantity. Next question will be on what factors the resistance will be depending upon, because we are saying resistance of the metallic conductor, அது எந்தெந்த factors மேல depend ஆகும், that is what we will want to know next. Okay, பாருங்க, what are the factors on which the resistance will be depending upon. So இங்க பாருங்க, we are taking a metallic conductor of cross section area எவ்வளவு a and length of the conductor is l. Okay, so across these ends இங்க தான் நம்ம voltage or potential difference apply பண்றது. Okay, and we are able to see the current going through this cross section area a. This is what is the typical setup of the metallic conductor. So on what factors the resistance will be depending upon. So this will be determined based upon the experimental studies. Okay, like எப்படி அந்த resistance ஓட value வந்ததோ இதையும் அப்படிதான், based upon the experimental studies. So experimental studies ல இருந்து the conclusion is the resistance, right, will be directly proportional to the length of the conductor. Okay, so means what, if the length is increasing means resistance of the value also will be increasing, and is inversely proportional to the area, means area increase panna resistance of the value கம்மி ஆயிடும். Okay, so இது ரெண்டு சேர்த்து நம்ம what is it that we can say, R will be proportional to L by A. இது மட்டும் கிடையாது, it will be depending upon the properties of the particular substance. Okay, so இப்போ பாருங்க, we are taking இது ஒரு copper metallic rod வெச்சுக்கோங்க, same as it is அந்த geometrical parameters வச்சு நம்ம இங்க ஒன்னு substance எடுக்கிறோம். இது என்னன்னா, this is same geometrical parameters, அங்க எப்படி இருக்கோ length, area எல்லாம் same as it is, but இது என்னன்னா, this is made up of iron வெச்சுக்கோங்க. Then what is observed is that the resistance of this rod 1 and சொல்லலாம், இது என்னது resistance of the rod 2, both have the same length, same area, but rod 1 oda resistance is different and rod 2 oda resistance is different. அதுல இருந்து என்னன்னா, the conclusion is it depends upon what is the material which is making up of the resistance. Okay, so this property which will be characteristic of the material, this is what we will be calling as resistivity and solute. What is it called as? Resistivity. So resistivity, we will represent this by the symbol rho, like நம்ம அந்த density symbol யூஸ் பண்ண தெரியுமா, அந்த மாதிரி தான் rho as it is. Okay, so resistivity is basically what, it is a property of material which relates to the resistance. Okay va, so the resistance oda relate பண்ண ஒரு physical quantity. இது எப்படி நம்ம resistivity of the material அது understanding பண்றதுன்னு சொல்லிட்டு we will discuss about it when we go to that drift concept தெரியுமா, அங்க we will talk about this, how we will be able to understand the resistivity property and சொல்லிட்டு. பட் இங்க என்னன்னா, just the overall understanding of the resistance. இப்போ பாருங்க, the resistance, right, is now made into an equation, so it will be equal to what, the property of the material which is rho, that is what we are calling as resistivity into L by A. Okay, so resistance, when நம்ம ஒரு கண்டக்டர் எடுத்தா அதோட resistance, right, will depend upon what, it will depend upon the geometrical parameters, அதோட length மேல depend ஆகும், அந்த மாதிரி area of cross section. அதுக்கப்புறம் it will depend upon what is the nature or the material type, and that dependency, right, அந்த ஒரு dependency on the material type or that nature of the substance is represented by the resistivity quantity. Okay, so the material oda dependency is represented by what, resistivity quantity. இங்க பாருங்க, we can we can get the expression for the resistivity. அப்படியே அந்த ஏரியா லெஃப்ட் சைடு எடுத்துட்டு போனா it will go to the numerator. Length எப்படி it will come to the denominator. பாருங்க R into A by L. So this is the resistivity. ஒரு மெட்டீரியலோட ரெசிஸ்டிவிட்டி நமக்கு வேணும்னா what is it? அந்த given object எடுத்துட்டு we will measure the resistance. Resistance measure பண்ணதுக்கு அப்புறம் resistance is equal to what? Rho into L by A தானா? So அதிலிருந்து if you are substituting the value of L and A means we will be able to get the value of rho. Okay. So rho is what? It is a property of the material type. Rho is what? It is a property of the material type. Okay. So இங்க பாருங்க resistance, right? So ஒரே ஆப்ஜெக்ட் இருக்கு நம்ம கிட்ட வெச்சுக்கோங்க. This is like a or cuboid type. It's like a cuboid. Resistance of that conductor that you are considering will also depend on across which face, through which cross section. Okay, so through which cross section current flows. This is an important point. And in the Madri questions we can get in, like theory based the Madri we will be able to get it. Like they will give us cuboid. They might ask us across which face the resistance will be least. And the Madri. This is the same material we are looking at. Same resistance, right? We can measure the resistance across the path AB. What is this AB path means? Current ipdi flow panna madri. So engane theriyuma, we'll consider the this is what the length we are taking it as what? A. Breadth we are taking it as what? B. Height we are taking it as what? C. Length we are taking it as what? A. Breadth evla B. Height is what? C. When you say that the current is flowing in that AB path and sonna, what is the area through which it will be passing? Idana, and the area oda value oru paranga, the area will be equal to what? A into B. And the madri, what is the length of the conductor that will be measured here? I'll represent by a different marker. Inga paranga, what is the length of the conductor that is measured? Idana. So paranga, what is the length of the conductor? Idana. What is it? C. So length of the conductor level is C. So when you're measuring the current flow in that path AB, then the area of cross section level, it will be what? A into B. Length into breadth. And the madri, what is the length of the conductor? It will be what? C. Okay. So paranga, depending upon which path the current is flowing, right? The resistance measured for the same object. Object. But the resistance measured will vary depending upon which direction the current is flowing. Okay, va? So if you take the path AB and ichkonga, what is the length? What is the length of the conductor here in that path AB? What is the length? It is what? C. And the madri area of cross section A into B, right? So what will be the resistance value? Rho into length. Length is C dana, divided by A into B. And the madri, we can also look at the other two paths. Other two paths, we have path CD irukka, and the madri path EF irukka. So what is the path CD? Path CD. Path CD edutha, the length. The length of the conductor and sonna, what is it? What is the length of the conductor? This is the breadth. Breadth B dana. And the madri, what will be the area of cross section? What is the area of cross section? Observe pananga, this is the area of cross section, right? So then this is A. Height C dana. So the area of cross section is what? A into C. What is the length here? Length is equal to the breadth part. So adanala the resistance along that path CD will be equal to what? Rho into B by AC. It will be what? Rho into B by AC. Okay, va? After that, we look at the other path for the flow of current. What is the last one? The path EF. Then the last one EF. Okay, if you look at the EF path, in the path, what is the length of the conductor here? It is A. okay. அது மாதிரி what is the area of cross section இங்க பாருங்க, what is the area of cross section, இதனது this is B C, so what is the area of cross section, B into C, so அதனால resistance will be equal to what, rho into A by BC. இங்க the kind of question that we can expect, right? எந்த மாதிரி questions கேட்கலாம், they can give us a cuboid கொடுத்துட்டு they will ask us across which path the resistance is maximum கேட்கலாம், or they can ask us minimum. இந்த மாதிரி questions we will be able to expect, okay va. So if you take that cuboid kind of the conductor or the resistor, depending upon the path of current, right, the resistance value will keep changing, okay va. So this is an important thing for questions in the NEET examination, okay va. So resistivity and solidity we mentioned about a new physical quantity, and a physical quantity varumbodhu, that's it, we have to look at what is the SI unit of the physical quantity, and the madri what will be the dimensional formula of the physical quantity, okay. Inga we talked about this resistivity and solidity. What is the resistivity oda expression, it will be R into A by L, idana. So inga parunga, resistance is what, ohm, area is what, meter square, SI unit, divided by length is meter. So cancel panna, what is it, ohm into meter. So resistivity oda SI unit anadi, it is what, ohm into meter, okay. And the madri what will be the dimensional formula for that, what is the resistivity oda dimensional formula, okay. Adukana if you are already remembering the dimensional formula for the resistance, means we can use it, okay. Illanna you will have to derive the resistance or dimensional formula derive பண்ணதுக்கு அப்புறம் என்ன பாருங்க, the dimensional formula for the resistivity, right, இங்கல இருந்து வரும், it will come from here only, R into A by L, okay. அதுக்கு என்னன்னா, if you are already knowing the dimensional formula for the resistance, இப்போதானே நம்ம பண்ணது, what is it, M L square I power minus 2 T power minus 3, இதுதானா, this is the dimensional formula for the resistance. அதோட அப்படியே area means what, L square, length means L, okay. பாருங்க, what is it, M L cube I power minus 2 T power minus 3, then this is the dimensional formula for the resistivity. Then what is it, this is the dimensional formula for the resistivity, okay va. Here we are talking about one more physical quantity, paranga, conductivity and solidity. What is it, conductivity. Conductivity enna theriyuma, generally we will represent this by the symbol sigma. The sigma symbol which we will represent it, okay va. So conductivity will be reciprocal of the resistivity. In the rendu physical quantity relation based panni we will see how the micro level behavior of the electrons will result in the current, and adella nama cover panna porom when we discuss about the drift concept, okay. So inga enna, just the relation between the two, what is it, the conductivity and resistivity, right, what is the relation between the two, they are reciprocal to each other. Reciprocal nu sonna we can say sigma is equal to 1 by rho and solla, or rho is equal to 1 by sigma. Ipo parunga, sigma is equal to 1 by rho, right, which means the SI unit of sigma will be what, 1 by ohm into meter. Idenna theriyuma, we can write it like what, ohm inverse meter inverse. What is the SI unit of conductivity, it will be what, ohm inverse meter inverse, okay. அது மாதிரி dimensional formula வேணும்னா, what is it, already நம்ம கிட்ட இங்க இருக்கா rho ஓட dimensional formula, அப்படியே நம்ம reciprocate பண்ணா, reciprocal means what, 1 by M L cube I power minus 2 T power minus 3, இதுதான், this is what is the dimensional formula for the conductivity. ஏன்னா just reciprocal of the resistivity value தானா. So அதிலிருந்து we will be able to find what is the dimensional formula for the conductivity also. Okay, so both conductivity or the resistivity rate, about them we will discuss when we go to the drift concept. Okay, so again just the understanding that the resistivity is a property of the material. It is a property of the material. Correlated to that, we have one more physical quantity, other is the conductivity. Okay, what is the relation between the two? Just they are reciprocal to each other. Okay, so which means what? For resistivity just then conductivity will be less. Conductivity is more means resistivity will be less. Okay, so this is about the factors on which the resistance will be depending upon. So it will depend upon the geometric parameters. Length will depend on area of cross section. Other best example I'm already paathirukom. What is it? Same ஒரே நம்ம cuboid shaped இது எடுத்துட்டு when you measure the resistance across different paths, since the geometric parameters are changing, right? So அதனால we saw that resistance values are also changing. அந்த மாதிரி the resistance also depends upon that material oda nature, that is given by the resistivity term. Okay va? So in fact the classification of the substances, so broader pathina we will try to classify the substance into what? Conductors which are able to easily allow the flow of current. The classification, right, should be based upon the property of the material. It should not be based upon the resistance, and resistance will depend upon the geometric factors also. So the classification of the materials, right, is based upon the resistivity. If resistivity kammiya irukku, then what it means? What is the relation we have? R is equal to rho into L by A. Geometric parameters are constant. Rho is less means what? Resistance also will be less. What is the current formula? V by R dana from the Ohm's law. V by I is equal to R. So I is equal to what? V by R. When the resistance is less, which means what? Current to the value will be higher. So means that particular material, right, is able to allow more amount of current to go through it. So those kind of materials, what do we call them as? Conductors and solvo. Typically the metals. The conductors will have a resistivity value. So we are fixing the temperature as what? 0 degrees Celsius temperature. What is the conductivity values? Conductivity values will be high. Resistivity values will be what? Low. The resistivity value is another 1.6 in 10 power minus 8. Silver or the copper 1.7 in 10 power minus 8. What is the range? It is all in very small range. Resistivity values will be what? Very, very less. Okay, so we can see a lot of aluminum, tungsten, iron, platinum, mercury. Okay, so generally based upon the cost factor, right, we know that silver is a good conductor. And the resistivity value, right, silver resistivity value is lesser than copper. But why we see in electrical wiring cell, we will see copper, we will not see silver. Why? Because there will be also cost factor, right? If silver wise use this is going to be very costly. Adhanala we will use the copper. Okay, so but broadly copper, aluminum, even some places we will see aluminum wires also. Copper, aluminum, silver, they are all what? Good conductors. We can see from the resistivity values also we will be able to see. Okay, and even we have mercury is also what? Good conductor. Nichrome, like nichrome is an alloy of nickel, iron and chromium. So adhoda resistivity it is what? 100 into 10 power minus 8. And other alloys also will be in that smaller resistivity range. At the level of we have semiconductors. So we have a separate chapter itself. Semiconductors and communication systems. That is the last one. Okay, so semiconductors what is the range? Broad range. Carbon graphite, what is it? 3.5 in 10 power minus 5. We have silicon, which is having a value of 2300. It's a broad range. Okay, insulators resistivity values will be very high. So pure water, what is it? 2.5 in 10 power 5. Glass, hard rubber, sodium chloride, fused quartz. So this can keep on increasing. The insulators, right, resistivity value will keep on increasing depending upon the type of the material. Okay, so main like there is no hard bifurcation. அது நம்ம கரெக்டாக ஞாபகம் வச்சுக்கணும். There is no hard bifurcation. We don't need to worry that in the values எல்லாம் நமக்கு ஞாபகம் வச்சுக்கணும்னு சொல்லிட்டு there is no requirement like that. ஏன்னா because there is no hard bifurcation. இப்போ பாருங்க, let us say there is a clear bifurcation இருக்குன்னு வச்சுக்கோங்க. Then we might be able to expect some questions like above which resistivity it will behave like a conductor, or above, like they can ask us some particular questions. But in Canada we don't have a clear bifurcation kadayadu. It is a broad range. Okay, so if it is in very lesser value, like in the range of 10 power minus 8, inga parunga, what is it? It's a range of 10 power minus 8. That is a broad range. They are all what? Conductors, typically metals. அதுக்கு அடுத்த லெவல்ல we have what? Semiconductors. அதுவும் broad range. இங்க பாருங்க, 3.5 10 power minus 5 ல இருந்து we are having all the way up to 2300. அதுக்கு அடுத்த லெவல் என்ன வருது? 10 power 5. அந்த லெவல்ல இருந்து we are going all the way up 10 power 16. That is what? Insulators. Okay, but என்னன்னா we don't have a clear cut demarcation மாதிரி கிடையாது. ஓகேவா? So this is about how we'll classify the materials based upon the resistivity or broad values. Okay, பாருங்க, we'll look at some sample questions. A wire, அதோட length கொடுத்திருக்காங்க. What is it? 250 centimeters and 1 millimeter square cross section area. So இங்க என்ன தெரியுமா? We have to be careful about the units. Carrying a current of 4 amperes when connected to a 2 volt battery. So 2 volt battery ஓட நம்ம கனெக்ட் பண்ணா அதுல what is the current that we are measuring? 4 amperes. So straight we can talk about what is the resistance. பாருங்க, what is the resistance? Applied voltage எவ்வளவு? 2 volt divided by what is the measured current? 4 ampere. அதுதானா? So what is it? It will be 1/2 ohm. இது the resistance value. Okay, அது அப்படியே இருக்கட்டும். What is it that we need to find? நம்ம resistivity calculate பண்ணணும். So resistivity formula என்ன? R into A by L தானா? ஏன்னா R is equal to what? Rho into L by A. அது நம்ம அப்படியே நம்ம rearrange பண்ணா rho will be equal to what? R into A by L. Okay, இங்க பாருங்க, R இருக்கு நம்ம கிட்ட half. We'll try to take everything in the SI system. SI system leta the resistivity will be coming in terms of what? Ohm into meter. Okay, இங்க பாருங்க, numerator we have area எவ்வளவு? 1 millimeter square. Millimeter square ன்னு சொன்னா what is it? Millimeter means what? 10 power minus 3 meter. Square பண்ணா what is it? 10 power minus 6 meter square. Okay, so then this is a ohm divided by what is the length? 250 centimeter means 2.5 meters. Check பண்ணுங்க, what is it? 2 into 2.5 means what? 5. So 10 power minus 6 by 5 ohm into meter. Okay, so what is the like we have it like 1/5 into 10 power minus 6. What is 1/5 means? 0.2 தானா? So 0.2 into 10 power minus 6 ohm into meter. Check பண்ணுங்க, what is it? What is the answer we must get? 0.2 into 10 power minus 6 வரணும். Okay, good Maithili. So what is it? Again answer, what is it? 0.2 10 power minus 6. Okay, ஏன்னா இந்த resistivity and resistance ஓட relation based பண்ணி we already got some questions in the previous year. Okay, so அதனால we have to be looking at this. Okay, so இந்த மாதிரி base level questions கிடையாது. We'll see some more different models of questions. Okay, பாருங்க, a wire has a resistance R. So நம்ம கிட்ட ஒரு wire இருக்கா, அதோட resistance என்ன R. What will be its resistance if it is stretched to double its length? So இங்க பாருங்க, இது ஒரு interesting question. So நம்ம என்ன பண்றோம், நம்ம கிட்ட இருக்கிற wire எடுத்துட்டு we are stretching it to double its length. Stretch பண்ணா என்ன ஆயிடும், see we are having a wire. Okay, so நம்ம கிட்ட ஒரு wire இருக்குன்னு வெச்சுக்கோங்க. Wire and சொன்ன உடனே what are the things we'll talk about, the length of the wire and the மாதிரி அதோட area of cross section. அதுதானா, this is having a resistance R, means what, R is equal to rho into L by A. இது நம்ம equation 1 அப்படி இருக்கட்டும். Okay, so இப்போ அடுத்தது என்ன, we are stretching that wire. So stretch பண்ணா we are stretching the wire to double its length. இப்போ பாருங்க, so we stretch the wire to double the length. Double the length and சொன்னா what will be the length value now, 2L. But அப்ப என்ன ஆகும், நீங்க பாருங்க, like even you can take some small இந்த rubber band மாதிரி எடுத்துட்டு you try to stretch the rubber band. அப்ப what is the thing that we'll observe, the area of cross section will keep decreasing. So இங்க நம்ம எடுத்தது என்ன, this is a metallic object, right? So அதோட volume, because நம்ம temperature change பண்ணலன்னா volume will be remaining constant. இங்க பாருங்க, temperature நம்ம change பண்ணலன்னா volume will be remaining what, constant. So volume constant means what, even if you change the temperature also volume அந்த அளவுக்கு change ஆகாது. So because we'll see in the properties of solids, right, the change in volume will be very very small. Okay, so we are stretching the length means area of cross section change ஆயிடும். Let us call it as what, A dash. Okay, so இங்க பாருங்க, what is the initial volume, இந்த rodோட initial volume என்னது பாருங்க, அதோட initial volume என்ன, what is the initial volume, A into L தானா, that should be equal to final volume A dash into 2L. And what is the relation between the two, is the same rod that you take. அப்படியே நம்ம stretch பண்ணா the area of cross section will decrease so that the volume will be maintained same. இங்க பாருங்க, if the volume is maintained same, then what is the A dash value, L அப்படியே cancel ஆயிடும். So இதுல இருந்து we'll get what, A by 2 is equal to A dash. So A dash value என்ன, A by 2. இப்போ பாருங்க, the new resistance R dash is equal to what, rho into, இப்போ length எவ்வளவு, 2L divided by area of cross section A dash தானா, A dash is what, A by 2. பாருங்க, 2 அப்படியே numerator போய்டும். So what is it that we have, 2 into 2 will be 4 times rho L by A. So what is rho L by A, equation 1 that is the original resistance, right? பாருங்க, so it will become what, 4R. so நம்ம ஒரு wire எடுத்துட்டு stretch பண்ணா to increase the length to twice its original value. so இங்க நம்ம எடுத்த assumption என்ன, the volume of that particular substance will remain the same. ஏன்னா temperature பத்தி நம்ம mention பண்ணல, so we are assuming the temperature remains constant, so volume is not changing. So apparently what is the result we are getting, the result we are getting is the final resistance is what, 4 times the original resistance. பாருங்க, what is the final result, the final resistance is what, it will be R dash will be equal to 4R. இது அப்படியே நம்ம generalize பண்ணலாம். generalize பண்ணோம்னா what is it, இப்போ பாருங்க, instead of saying double and சொல்றதுக்கு பதிலா we are saying that no, the wire is stretched so that the length becomes n times the original length அப்படி சொன்னா வெச்சுக்கோங்க. so இதான generalize பண்ணது. so instead of saying double we are saying the length becomes what, n times the original length. இப்போ பாருங்க, what is the final, so it is the initial length L, area of cross section A. final state la what is the length, NL, area of cross section நம்ம A dash ன்னு சொல்லலாம். இங்க அப்படிதானா, volume will be remaining constant, which means A into L is equal to A dash into NL. இப்போ பாருங்க, LL cancel ஆயிடும், A by N is equal to A dash. இதை வச்சு we will be able to find what is the new resistance. பாருங்க, what will be the new resistance, R dash, R dash will be equal to what, rho into what is the new length, N times L divided by A dash. A dash is what, A by N. இங்க என்னன்னா அந்த n அப்படியே numerator போய்டும். so n into n will become what, n square into rho L by A. what is it, R dash will be equal to N square into R, your standard result. So நம்ம கிட்ட இருக்கிற resistance, அந்த resistance wire, right, அப்படியே stretch it to N times the original length. அப்படி stretch பண்ணா then the final resistance will be equal to what? N square times the original resistance. Okay, so final resistance value என்ன? N square times the original resistance. இப்போ இந்த மாதிரி நம்ம standard results நம்ம கிட்ட இருக்குன்னு வெச்சுக்கோங்க, we will be able to solve the questions with much more ease. இப்போ இந்த மாதிரி ஒரு question வந்ததுன்னா they are saying, you know, the length of that wire is increased to 5 times the original length. Then what is the new resistance? அப்படி கேட்டா, if you remember the result, right, we will be able to answer the question easily. What will be the answer? N square times the original resistance. அதாவது N square times the original resistance சொன்னா 5 square will be what? 25 times. அந்த மாதிரி. Okay, இங்க பாருங்க, a copper wire of resistance 4 ohms is melted and redrawn to thrice its original length. இங்க பாருங்க, same type question. So copper, அதோட length நமக்கு தெரியாது, area of cross section நமக்கு தெரியாது, but என்ன இருக்கா, நம்ம கிட்ட resistance இருக்கா. What is the resistance value? 4 ohms. இங்க என்னது, we are melting it, melt பண்ணதுக்கு அப்புறம் we are redrawing it to thrice its original length. நீ அப்படிதான், when we make it into 3 times the original length, volume will remain constant, right? அப்படிதானே, volume is going to remain constant. Volume constant means, இப்போ தான் நம்ம அந்த standard result பார்த்தது, what is it? The length is made to become what? 3 times the original length. அப்ப என்ன ஆயிடும், the area will become 1/3 of the original area. So then finally what is the conclusion? நம்ம கிட்ட அந்த result இருக்கா. What is it? R dash will be equal to what? N square into R. அதுதான formula. So N ஓட value என்ன? 3. So it will be what? 3 square into R is 4 ohms. பாருங்க எவ்வளவு சிம்பிளா வருது ஆன்சர். 3 square means what? 9. 9 4s are what? 36 ohms. அவ்வளவுதான். Okay, so if you're looking at these standard models of questions, right, இந்த மாதிரி we will be able to quickly solve the questions. Check பண்ணுங்க, what is the answer for this? It is what? 30.